Hello everyone, welcome to Chemitarian. In today's lecture, we are going to cover Markovnikov and anti-Markovnikov rule. Okay, so basically Markovnikov rule have two statements. The first statement or the first rule is that if we are going to talk about the unsymmetrical alkenes, okay, the unsymmetrical alkenes such as CH3, CH double bond, CH2. So this is an example of unsymmetrical alkene in which if we add HX, okay, so HX gives us H plus and X minus. H plus is a electrophile and X minus is a nucleophile. Okay, so in this reaction, the hydrogen goes to that carbon which already contain more number of carbon. The first rule of Markovnikov is that the addition of HX in unsymmetrical molecule done in a such a way that H plus goes to that unsaturated carbon which wearing more number of hydrogen. Okay, so the H plus goes to that carbon and the X minus goes to the carbon which contain less number of hydrogen, and the final product is CH3, CH, CH2, H plus and Cl. Okay, this is the first rule of Markovnikov. Okay, so you have to follow the instruction about the Markovnikov rule is that if we are going to talk about CH3, CH2, CH and CH2. Okay, this is an unsaturated unsymmetrical alkene and we have to add HBr. Okay, so HBr gives us H plus and Br minus. After that we add hydrogen to that carbon which already contain more number of carbon and bromine to that carbon which contain less number of carbon. Okay, so the final product is CH3, CH2, CH, Br and CH3. In case there is any chances for the rearrangement, so we can do the rearrangement, and about the rearrangement we are already discussed. So if there is chances for rearrangement, we absolutely we can do it. Okay, so suppose there is an example CH3, CH, CH3, CH and CH2. Okay, so without any doubt H plus goes to that carbon which contain more number of hydrogen. Okay, so H plus goes to that carbon and it forms CH3, CH, CH3, CH plus and CH3. Okay, so there is possible chances of rearrangement because if we shift these alpha hydrogen to here and positive charge here, so we can obtain a more stable carbocation which look like this CH3, C, CH3, CH2, CH3 plus. Okay, so A and B. A contain 4 alpha hydrogen, B contain 8 alpha hydrogen. So B is more stable than A, so this rearrangement can possible. Okay, so in the end of the Markovnikov rule, we have to always understand more stable carbocation give us a major product. Okay, so the product is CH3, C, CH3 and Br and CH2, CH3. Okay, so the first rule of Markovnikov is that if we are going to add a molecule like HX in a unsymmetrical alkene, hydrogen goes to the carbon which already contain more number of hydrogen and halogen goes to the other carbon. But if there is any chances of rearrangement of carbocation, we do the rearrangement and find the most stable carbocation, and after that we add the nucleophile to the most stable carbocation. Okay, so this is the first rule of Markovnikov. The second rule of Markovnikov, if we are going to talk about vinyl halide. Okay, so firstly we have to clear what is the vinyl halide. When in any compound there is double bond and halogen, both are present, the molecule is known as vinyl halide. Okay, so if we add HX in vinyl halide, Okay, so if we add HX in vinyl halide, the halogen goes to that carbon which already contain a halogen. Okay, so the product is CH3 CHX2. That is the second rule of Markovnikov. In a vinyl halide, the halogen goes to that carbon which already contain a halogen. Okay, so these are two rules of Markovnikov which say that first rule is say that when molecule of HX add in unsymmetrical unsaturated hydrocarbon, the electrophile goes to the unsaturated carbon atom bearing more number of hydrogen. But in a vinyl halide, halogen goes to that carbon which already contain an other halogen atom. Okay, so these are two reactions, but we have to always notice that in Markovnikov rule there is more stable carbocation give us major product. So if there is any possibility of rearrangement of carbocation, we can do it. Okay, so if any possibility, then rearrange the carbocation. Okay, so this is the Markovnikov rule. And let's talk about anti-Markovnikov rule. So as we already discussed in previous video that Markovnikov rule is an example of electrophilic addition reaction. Okay, Markovnikov is the example of electrophilic addition reaction. So this is an example of electrophilic addition reaction in which carbocation rearrangement is possible. On the other hand, if we are going to talk about anti-Markovnikov rule, so anti-Markovnikov's rule in which there is presence of peroxide. Okay, and this is a free radical addition. This is a free radical addition reaction. Okay, so this is also called as Kras effect or peroxide effect. Anti-Markovnikov rule also called as Kras effect of peroxide effect. Okay, and this reaction follow free radical mechanism. Okay, this reaction follow free radical mechanism. Okay, so let's talk about what is the anti-Markovnikov rule. The opposite of Markovnikov is a anti-Markovnikov rule. Okay, so suppose we took a unsymmetrical alkene like CH3 CH double bond CH. Okay, so according to Markovnikov rule, hydrogen goes to that carbon which already contain more number of hydrogen. Okay, so the product is CH3 CHX and CH3. But according to anti-Markovnikov, in the presence of peroxide, the hydrogen goes to that carbon which contain less number of hydrogen. Okay, so the hydrogen goes here and halogen goes here. But this reaction follow free radical mechanism in the presence of peroxide. Okay, and one more thing, the peroxide effect obtain or observe only HBr. Okay, only HBr shows peroxide effect. In the case of HCl, HF and HI, in the case of HCl, HF and HI, we cannot observe the peroxide effect. Okay, so even presence of peroxide, we can follow Markovnikov rule on the addition of these halides. Okay, so only HF follow anti-Markovnikov rule. Okay, so suppose we took another example, that is CH3 CH CH3 CH double bond CH2. So this is the free radical mechanism, so there is no rearrangement. We can add HBr in the presence of peroxide RO. So the product is CH3 CH CH3 and hydrogen goes to that carbon which contain less number of hydrogen according to anti-Markovnikov, and bromine goes to that carbon which contain more number of hydrogen. So this is our final product without any rearrangement. Okay, but if this reaction take place in the present according to Markovnikov or in the absence of peroxide, the final product is CH3, CH3, Br, CH2 and CH3. Okay, so after the rearrangement, this is our final product according to Markovnikov, and this is the final product according to anti-Markovnikov. Okay, so anti-Markovnikov follow free radical mechanism. So free radical mechanism contain three steps. First step is initiation, the start of reaction. Okay, so first step is initiation, the start of reaction, in which firstly the peroxide ROOR goes under homolysis in the presence of sunlight, and it forms RO free radical. This is the free radical. After that, RO free radical attack on HBr and it gives us Br free radical. So this is the first step of initiation of the reaction. After that, the second step is chain propagation, which provides us the major product of the reaction. Okay, so in chain propagation, CH3, CH, double bond CH and Br free radical. Okay, so after chain propagation, Br attached to the carbon which contain less number of hydrogen. Br less number of sorry more number of hydrogen, and it forms CH3, CH free radical CH2Br, and after that one more HBr attached to this and it forms CH3, CH, CH2, Br and Br free radical. After this, the third step is termination. So termination is the final step for the free radical mechanism, where all the free radical attach to each other and form all the possible product, like Br free radical form Br2, RCH, CH2, Br react with Br free radical form RCH, Br, CH2Br. These are byproduct for the reaction, and this is the final step of anti-Markovnikov. So we have to notice that if we are going to talk about any unsymmetrical alkenes, so their unsymmetrical alkenes like R, CH, CH. Okay, so if we are going to talk about any unsymmetrical alkene, so there is two types of rule on the addition of HX. One is Markovnikov and other is anti. According to Markovnikov, stable carbocation give more major product, and according to anti-Markovnikov, the hydrogen, the halogen goes to that carbon which contain more hydrogen, halogen goes to that carbon which contain more hydrogen, and hydrogen goes to that carbon which contain less hydrogen. Okay, but according to Markovnikov, halogen goes to that carbon which contain less hydrogen, and hydrogen goes to that carbon which contain more hydrogen. Okay, it is a free radical reaction and it is a electrophilic addition reaction. Okay, it is also called as Kharash effect. It observed in HCl, HBr, Hi and HF, but it observed only HBr. Thank you for watching.